So we want to maximize daily revenue on this problem. On all kind of problems like this where you want to maximize something, we've been studying quadratic equations and looking at the graphs of those and finding the vertex. Our vertex is what gives us our maximum. So if we can write a quadratic equation for this, then we just need to find our vertex. That will tell us the maximum amount of revenue we can have and how many bicycles per day that we'd have to rent in order to achieve that. So, what do we know? We're renting 90 bicycles a day for $8 each bike. And for each $1 we increase the rate. So, say we want to rent them for $9 a day. That's $1 increase from what we currently have. Then we're going to rent 4 fewer bikes because not as many people want to pay $9 as opposed to will pay $8. So from this information, we've got to find some equations and then figure out what our quadratic equation will look like. After that, it's just applying the vertex formula. In general, how much money that we make renting bikes is going to be the number of bikes times how much we charge per day. So that's how we would figure that out. Now what we want is we're going to let X be the number of bikes. Because see, this is going to vary. Because the number of bikes that we rent, it depends on how much we're going to charge. And then we're going to let P be the price. So that's the price that we're renting. So we can rent 90 bikes if we only charge $8. But we're going to lose bikes for every dollar that we increase that $8 rental fee. So we're going to lose 4 bikes every time that we increase that. So we're going to lose 4 bikes times however many dollars that we increase our rate. So the price minus the $8 will tell us what the increase is. So this piece here, the P minus $8, tells us how much we've increased the rate from $8. And we'll multiply that by 4 to find out how many fewer bikes that we are renting at this new price. So that is going to be the number of bikes that we can rent. So what we need to do is we need to clean this up. So we'll go ahead and distribute the 4. We have 4 minus 4p, and then the minus 4 times 8 will give us a positive 32. So we can combine our 32 and our 90 to get 122 minus 4p. Now this represents the number of bikes that we're going to rent at any given price over our $8 here. So our revenue, how much money are we going to make? Our revenue in terms of price is equal to however many bikes that we rent times the price. So we have a new expression for X that is in terms of P. That's this down here. So we're going to plug that in where the X is up here. So that is equal to 122 minus 4p, and we're multiplying that by the price. So when we do that, we'll go ahead and distribute the p. So we have 122, sorry, my writing doesn't look great, 122p, because we multiply that by the p, minus 4p squared. Now that should remind you of a quadratic equation because it is. It's got the p squared in it. So if you want, you can rewrite it. And I'm going to use red here so I don't run into the stuff that I already have written down here. And put the p squared first, that term. So minus 4p p squared plus 122p. Now we just need to apply our vertex formula to this quadratic. Now that we have our quadratic equation, we can apply the vertex formula. And now the vertex formula says x equals negative b over 2a. Well, we've already set our x to equal number of bikes, so that doesn't really apply here. Our equation is in terms of p, so we'll actually say p is equal to negative b over 2a and apply that here, where your negative 4 is your a, the 122 is your b, and you don't have a c, but we don't have that in the vertex formula anyway. But when we find that out, we'll have p equals, I'll write that over here. So in this case, because our quadratic, again, because it's in terms of p, we're going to write p equals instead of x equals. But p equals negative b over 2a. So that's going to tell us this first part, the rate that we should use to maximize this, because that's part of our maximum here. And then after we find this, we'll plug that back in. Whatever we find here for p, we'll plug back into this, and that will give us the second part, the answer for the second part of this question.